T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up. T-minus 10, 9, 8,
The clock is
7.
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle up.
We're trying to go where no one or no robot has gone before. There are areas on Mars, the surface of Mars, that we think to be very rich with new geology, mineralogy, atmospherics that current robots can't access. So we're trying to develop a new type of rover, more intelligent, more agile, to get to these regions. Now we're trying to do something much harder. In so successful as was this last rover, we now want to climb cliffs. We have a cliff butt. And the idea here is like a team working to allow a climber to belay or climb up. We have a team of robots. We have 3 robots, each active, each able to see, each able to conduct its independent control. All 3 are working together as a team to allow one to go up and down cliffs as steep as 75 degrees. Thus, we're trying to create a new generation of rover, of mobile robot that can go into regions that are very steep, even cliff-like, 70, 75 degrees. Compare that to current rovers, which can only traverse perhaps 15 to 20 degree grades and small obstacles. To allow rovers to go into these very difficult regions, ones that are very steep, very rocky, we have to give them an agility that is behaviorally intelligent. That is, they have to be able to recognize they're entering a difficult region. They have to be able to control themselves in a way that will allow them to safely access and traverse the regions. Think of your family dog or cat. They respond accordingly when they see a very difficult obstacle or area they have to climb or walk through.
T-minus 10, 9, 8,
The clock is operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle left.
Concept that we have is that this system consists of 3 robots that are connected when they land on the Martian surface, and then they sort of seek out to find the cliff edge, and then when they get to the cliff edge, they separate. 2 of them get the role of being the anchor points, and the third one becomes the repeller, and then they cooperate to send the third robot down. In order for the robots to collaborate with each other, they have to exchange some information, and one way of exchanging information is to have wireless communications. And basically using wireless links, the robots are forming a local network for themselves, and they can pass messages back and forth. And for instance, the repeller robot or the cliff bot can tell the anchor robots which direction it's trying to move in, and the others can basically try to synchronize their actions with the action of the cliff bot in order to accomplish the task safely. One of the motivations for doing this kind of work is there has been recent imagery, orbital imagery of Mars, the Martian surface, that indicate that there may have been water outflows on cliff sides. And the scientists are really interested in getting to those locations in order to take some data with instruments on the robot. And the current conventional rover technology is not capable of getting access to those kind of high-risk areas, but it has very high value from a scientific point of view.